Hey guys, welcome back to AlgoYogi. We are doing two pointer series. Our next problem in the list is number of subsequences that satisfy the given some condition. Let's go to the problem on LeetCode. And description is you are given an array of integers nums and an integer target. Return the number of non-empty subsequences. Subsequences are not the consecutive subarrays, so there is a difference. Subsequences are the values that you can choose from, but in the same order that they are occurring in the integer array, such that the sum of the minimum and maximum element on it is less or equal to target. Since the answer may be too large, return it by modulo 10 to the power 9 plus 7, right? That could be the largest integer that we are talking about in Python. Okay, so let's understand how we're going to do it. Okay, let me switch the view here. So this is our nums array. This is our nums array. And this is the target. We need to choose some subsequences. So let's understand by subsequences what we are talking about. So choosing subsequences from this array nums, what I mean is I either have a choice to basically choose a value or I don't. So let's say here I choose the value 3, as my first choice, and the second I don't. Then in later for this value I was talking about 3, and then we go on to 5. Here I either choose 5, I hope you guys can see it, or you don't. And for this position either you choose 5 or you basically don't. Right? So these values, when these basically this tree structure that we are creating by making a decision that if either we are choosing the value at a particular index as we are moving like forward, either we choose that value or we do not. And we end up, after iterating over the entire nums array, we end up at the leaf nodes. And that's where we basically get all the combinations or permutation, whatever you guys call it. So those will be the subsequences. And out of those subsequences, we will pick minimum and maximum, and then just add their values and just check the condition if that value is lesser than or equal to the target value, which is 9 here. So let me clean up, and for our first example, let's find the answer. So along with 3, we could choose just 3, since 3 itself is a non-empty subsequence. So here minimum and maximum is 3. So 3 plus 3 is lesser than or equal to 9. Yes, it is. So that's one of our answers. Second, along with 3, we could choose 5. That is another valid pair, or I would say sequence. Pair is in terms of minimum and maximum, but subsequence is what we are looking for. So this also satisfies our condition, which is 3 plus 5 is 8, lesser than or equal to 9. Satisfy our condition. That's another pair. And then 3 and 6. So 3 plus 6 is also lesser than or equal to 9. But here is the thing. Now, how about if since we were talking about the choosing basically the subsequences, what if we are picking up the minimum and maximum values, but there are some other values that exist between those. So what I really meant is, like, we choose 3 and 6 again as minimum and maximum, but in between we take the 5. So because 5 here, it doesn't matter. Maximum is 6, minimum is 3. So at the end of the day, for our condition, we'll be adding 3 and 6 lesser than or equal to 9. That also satisfies a condition, but this appearance of 5 doesn't really matter here. So in this case, we have four subsequences that satisfy our condition. That will be our answer, right? So that will be our answer. So how about we just basically go over each value, and for each value we basically have this another pointer pointing at the back of the array, at the end of the array. Let's say for 3 I'm starting for 3, and my right pointer is pointing to the end. How many values I see here, whenever I add those values, these are the values that I'll be basically choosing as my, this is my minimum. Okay, this is my minimum. And before I start that iteration, in this example they sorted the array, but like we'll have to sort our array to basically solve in this way, to basically using the 2 pointers. Since we are talking about minimum and maximum, minimum will be in the front and maximum in the end in a sorted array. So 3 will be fixed, and then we choose either any value from the remaining array, as long as it satisfies the condition. Okay, so 7 here, we will pick 7. Does this satisfy the condition? No. So maybe bring the r closer to a lesser value. So then we will pick 6. This does, right? This does. And if it does, then what I'm going to do is I will basically add to my result 2 to the power r minus my I. And the reason I'm doing this, so we use two asterisk here, by the way, to calculate the power. So the reason I'm doing here this basically 2 to the power r minus I takes care of all the combination that are going to happen between 3 and 6. So all those values, so in this case it's 3 5 6 and 3 6. So this is one pair and this is second pair. These 2 subsequences are considered, but there might be case where there were a lot of values that were present. In that case, this is what takes care of. Why? Because in this case, let's try it on our basically this example. So that will be 2 to the power, what is r here? 0 1 2 3. R is basically 2 minus 0, 2 minus, I'm pointing it over here, 0 1 2, 2 minus 2, that is basically, no, 2 minus 0, that is 2, but basically this is my right, 2 minus 0, which gives us 2, and 2 to the power 2 is basically 4. So 4 is the number of subsequences, and this is like too much shit going on here, so I'll just erase this. So 4 will be the number of subsequences when I choose 3 as my first value, right? That is pretty understandable. So 3 gives me 4 subsequences. What about when I move to 5 as my first value? Then I think there is no combination in this particular example that gives us that answer. So I think we're gonna just let it go, because 5 is the minimum, and then you add like 5 7, that makes it 12, and that's not pair that we want to, that satisfy the condition. So okay, let's write down the solution here. That will be basically big of n time complexity and space. I think we're just doing for the wait a second, no, I think that will be big of n square time complexity actually, since we are basically moving. I think, is it going to be big of n square? So what I really do is I'm doing it for all the element, but then I move the basically my right pointer again. I'm setting it. So yeah, it could be set to big of n square. Okay, so then I would say let's move to basically write down the code. Okay, so let's just write our solution now. Okay, so initially let's have our result variable having the value 0, and then we're gonna point our r pointer to basically pointing to the end of our array nums. Okay, and then we're gonna start a for loop for I and let's say value in enumerate. And what are we enumerating? Our integer array nums. And we're gonna say while I is lesser than equal to r, since this time same value could be, could make the minimum and maximum of that pair in the subsequence we're talking about. So that could be the case, and the value plus nums r at r is basically, if this is greater than target, then what we want to do is we want to basically keep decrementing our r. Okay, we keep decrementing. Otherwise what we want to do is we're gonna check if again this I is lesser than equal to, because sometime it might happen, they just cross each other, although they shouldn't, but because we are checking it right here as well, but this might fail. But it might happen that they were equal, then this passed away, this thing passed, but it became basically greater than r. In that case we also want to check it if we want to use that value. So if this is the case, then what I want to do is result plus equal would be, as we talked about, that will be 2 to the power r minus I, right? R minus I, and let's also mod it right here, but while calculating this, what might happen is res equals to res mod, and they have given us we have to return it by, let me just write this value, mod would be 10 to the power 10 to the power. Let me zoom out, and so that you guys can see also. This is what I'm talking about. This is the value that they gave me. So 10 to the power 9 plus 7, and we have to basically mod our result with that, and then we basically return our result. Okay, I think that is it. And yeah, okay. All right, I think, and also yes, we forgot, and I forgot about the space and time complexity. Well, because I completely forgot about nums dot sort. We need to sort the array, and although this is big of n, although this is happening in big of n, but this one is basically big of n, n log n. Okay, so this is max of the time complexity that will happen here. But before that, I want to run it on the example and see what it says. Okay, passes. Let's submit it. Please. Yes. Okay. So time complexity because of sorting. Big of n log n, let me just bring them closer. Space complexity is going to be big of 1, right? Okay, so let's go back to AlgoYogi, mark this solved, and see you guys later in the next problem. Until then, bye bye.